Alright, so today we're going to take a look at volcanoes a little more in depth. You've done a little bit of research and now we're going to add some information to go along with it. So you need to pull up your assignment number 6 volcano notes, and we will walk through these notes together. So first thing we want to address is the silica content. Silicon and oxygen, that Si and that O, are the two most common elements in our Earth's crust. And so we see in the lithosphere, that top layer of crust and upper mantle, there's a lot of silica. We have 61% silica in the lithosphere, whereas the asthenosphere, lower down the middle mantle, has less silica at 45%. So keep these numbers in mind as we go through the 3 locations where volcanoes form. So the first location we'll talk about where volcanoes form, you are very, very familiar with. This is where we live in Mount Rainier, is a great example of a subduction zone volcano. So subduction zone volcanoes form when you have that one tectonic plate being pushed under another tectonic plate. And other than Mount Rainier, there are many subduction zone volcanoes around the world. Another example would be Krakatoa, located over in Indonesia, where you have the Australian plate moving toward and actually sinking under the Eurasian plate here. So these subduction zone volcanoes, we want to know, well, where is their magma coming from? If this is the thing that makes one explosive and one gentle, we want to know, like, what's the source? Why? So for these subduction zone volcanoes, you can see that that lithosphere, that plate, is sinking under, and it actually melts when it gets down that far, when it gets warm enough. So this magma in subduction zone volcanoes is coming from the lithosphere. It's coming from another tectonic plate that melts and comes back up because it's so warm. A divergent boundary is the second location we find volcanoes on our planet. And at a divergent boundary, you have 2 plates moving away from one another. And a great example of a volcano found at a divergent boundary would be this black smoker chimney. And that is found over in this area where the Pacific plate is moving away from the Nazca plate, or vice versa, Nazca away from Pacific, moving away from each other. Now this divergent boundary, magma's coming from somewhere, and we certainly don't see one plate going under the other here. So if we start to think about it, that magma is actually coming from deep down in the mantle from the asthenosphere. Now the third location we find volcanoes here on our planet Earth would be at something called a hotspot. And we haven't talked about hotspots before, but it turns out they're pretty important when we're talking about why volcanoes erupt so differently. So a hotspot is just this bunch of magma, or a plume of magma, that starts to rise up because for some reason it gets really hot. It rises up, it burns through the crust, and it forms a volcano right above it. So the hotspot itself here actually stays still, but the plate moves over top. Let's look at a different view of this. So again, here's our plume, our hotspot, and here's our plate moving over our hotspot. And you can see as the plate moves, you get this chain of volcanoes poking through and sometimes coming above the surface of the ocean. Here's one more view. You can see as the plate is moving, the older volcanoes shift away from the hotspot, and then little baby volcanoes are forming right above the hotspot. So one example of a hotspot volcano is the Tahiti Islands, kind of down there in the South Pacific Ocean. And you might be asking, all right, well, what about the magma? Where is that magma coming from? There's no plate melting here. And so where that magma is coming from that comes out of these hotspot volcanoes is, again, down in the asthenosphere, just like we saw with the divergent boundary. So now you're going to try your hand at this and see if you can start to classify some more examples. We already talked about the examples of Krakatoa, the Black Smoker, and Tahiti, but I want to see and I want you to practice looking at the silica and trying to figure out what location that volcano formed in. So if you look back at your number 5 assignment, magma sampling, and you check out those first 8 samples, you should be able to look at the name and put that name in your example box for your notes based on the amount of silica. So for example, number 1 is Mount Rainier, and you're going to look at the amount of silica it had, and you're going to think, well, did that come from maybe the lithosphere at 61%-ish, or did it come from the asthenosphere at 45%-ish? And you're going to try to think about, should I put Mount Rainier in the subduction zone examples, the divergent boundary examples, or the hotspot examples? Try your hand at this. Good luck.